Hey everyone, welcome back. If you're a mechanical engineering fresher gearing up for your first design engineer interview, this one's for you. I'm covering the top 15 questions interviewers actually ask freshers, with simple, easy to remember answers for each. Let's get started. Quick overview before we dive in. The first 5 questions cover strength of materials, stress, strain, safety factor. The next 4 cover drawings and GD&T. And the last 6 cover CAD and general design practice, BOM, FEA, materials, and more. Let's start with question 1. Question 1. What's the difference between stress and strain? Stress is the cause, strain is the effect. Stress is the internal resisting force per unit area when a load is applied, measured in megapascals. Strain is the resulting deformation, change in length over original length. Cause and effect. Question 2. What is factor of safety? It's the ratio between a material's maximum strength and the actual stress it faces in use, basically a built-in safety cushion. Remember, higher factor of safety means a safer design, but usually heavier and more expensive too. Next, ductile versus brittle materials. Ductile materials, like mild steel or aluminum, stretch and bend a lot before breaking, giving you a warning sign first. Brittle materials, like cast iron or glass, snap suddenly with almost no warning. The difference comes down to how much energy each absorbs before failing. Question 4. What are the main load types? 5 basics: tensile, or pulling, compressive, or pushing, shear, or sliding, bending, and torsion, or twisting. Real parts usually face a combination, so as a designer, you always check the worst-case combination first. Question 5. Fatigue failure. It happens when a part breaks from repeated cyclic loading, even if each load is well within the material's strength. A tiny crack starts at a stress point and grows slowly until it suddenly fractures. That's why shafts and springs are designed with extra care. Moving into drawing and GD&T. Question 6. First angle versus third angle projection. Both just arrange drawing views differently. First angle, used in India and Europe, places the top view below the front view. Third angle, used in the US, flips it, top view above the front view. Question 7. What is GD&T? It stands for geometric dimensioning and tolerancing, a symbol-based language on drawings that defines exactly how much a part's form, size, and location can vary. It removes ambiguity for manufacturing and inspection. Question 8. Tolerance, allowance, and fit. Tolerance is the allowed variation on one part's dimension. Allowance is the intentional size difference designed between 2 mating parts. Fit describes how tight or loose those parts sit together, based on their tolerances. Question 9. The 3 basic types of fits. Clearance fit always has a small gap, so parts assemble easily, like a shaft in a bushing. Interference fit overlaps and is forced together tightly, like a bearing pressed into a housing. Transition fit could go either way, depending on the exact sizes. Now, CAD and design practice. Question 10. What's a BOM, or bill of materials? It's a complete list of every part, subassembly, and raw material needed to build a product, with quantities. Purchasing, manufacturing, and assembly all rely on it. Accuracy here is essential. Question 11. Part file versus assembly file. A part file is one individual 3D component. An assembly file combines multiple parts using mates or constraints to build the full product. Edit the part once, and it updates everywhere it's used. Question 12. What is FEA, finite element analysis? It's a simulation that breaks a part into thousands of tiny elements, called a mesh, to predict stress, deflection, and safety factor under load, before you've built a physical prototype. It catches problems early and saves time and cost. Question 13. Welded versus bolted joints. A welded joint permanently fuses parts together with heat, rigid, and can't be taken apart. A bolted joint uses fasteners, so you can open it up for maintenance or replacement. Choose bolts for serviceability, welding for permanent strength. Question 14. Heat treatment. It's controlled heating and cooling of metal to change its structure and improve properties like hardness or toughness. Common types: annealing softens it. Quenching and tempering hardens it. Case hardening gives a hard surface with a tough core. And normalizing refines the grain structure. Last one. Mild steel versus cast iron. Mild steel has low carbon, around 0.3%. Ductile, easy to machine and weld, used for structural parts. Cast iron has higher carbon, 2 to 4%. Brittle, but excellent in compression and wear resistance, which is why machine bases and engine blocks use it. And that's all 15. Practice explaining these in your own words, back each one with a real project example, and you'll walk into that interview with real confidence. If this helped, hit like, subscribe for more mechanical engineering content, and let me know in the comments what you want covered next.